Hello everyone, am I audible? Gautam Abdul. All right. We are starting in a few minutes. Gautam, have you finished the NCERT permutations? Not yet. All right. Please finish it till the next class. Today we're going to finish the chapter permutation and combination. We are starting in a few minutes. Which exam, Gautam? Like the final exams? All right. So are you going to attend the classes or not? We are going to finish the chapter 3D in the next week. So please attend the classes. Don't miss it. Okay, let's start with the question. All right, try to solve this question. Lines L1 and L2 are parallel to each other. Three points are taken on L1 and 4 points are taken on L2. How many new straight lines can be drawn passing through these points? All right, the question is, there are two parallel lines. Here we have 3 points. This is L1. In L2 we have 4 points. How many straight lines, how many new straight lines can be drawn passing through these points? All right, try to solve this question. I'll give you a few minutes. Good evening, Shapya. This is the first question of today's class. Yeah, no worries. Try to solve this question. All right. Ashma, you too. The question says there are two parallel lines, L1 and L2. L1 we have 3 points. In L2 we have 4 points. How many new straight lines can be drawn passing through these points? All right. How many straight lines are possible passing through these points? All right. Try to solve this. See, these are the geometrical problems, all right? These are called geometrical problems. How to solve this? To get a straight line, you need 2 points, right? 2 points can make a new straight line. But in here, if you choose these two, then this line is not new. Even this two is not new. So we cannot choose any 2 points between these three or these four, right? We have to choose one from this, one from this to get a new line. Is this clear, everyone? Shabya, Gautam, Ashma, is it clear? You need,
Yes, sir.
yeah, 1 point from this, 1 point from this. So we have 3 points in L1, so 3C1, 4 points on L2, so 4C2. Should I multiply this or add this?
Add.
Add. All right.
No, sir.
Ashma? Multiply. All right. Ashma, what do you say? Shall I add them or multiply them? Ashma is not here, I think. Gautam,
Sir, add.
add. Why add?
Sir, because
See,
it can only take two points only. It should be straight line. So you don't have very much choices.
okay. But see, when I'm writing 3C1, that means I'm choosing one point from L1. And when I write 4C1, I'm choosing 1 point from L2, right? So to get a straight line, I need to take this and this. I cannot choose one of this or this. Is it clear, Gautam?
Yes, sir.
We need both of this, right? We need to choose one from this and this. Both are compulsory. So we have to multiply 3C1 into 4C1. So the answer is 12. All right. All right, Ashma. Okay. No worries. You can answer on chat. All right. Ashma, is this question clear now? All right. And Shravya, clear?
Yes, sir.
All right. This is called geometrical problems. Write it down. Geometrical problems. All right. Another question on this. You have to think somewhat out of the box here, right? To get a straight line, you need 2 points like that. And then you can move on with the question. Another question. How many diagonals can be drawn in hexagon? All right, try to solve this. You can try to draw and count, or you can use permutation and combination and find the answer. All right, how many diagonals can be drawn in a hexagon? All right, few minutes for this. So where you almost got the answer, but you missed one little thing. All right, when you write 62, you get all the lines by taking any 2 points, right? So if I take one or two adjacent points, then that's not a diagonal, right? If I take one this and this, so I do not get a diagonal. So you need to do something about that. Think about that. See how to solve this? Very easy again. Wait a minute. Yes. So in a hexagon, 6 points we have, right? And for a diagonal, you need to connect 2 points, right? But they should not be adjacent ones. So let me do one thing. We have in total 6 points. So any 2 points will give me a line. If I subtract all the sides from this, then whatever is remaining will be the number of diagonals. Is it clear?
Yes, sir.
Yeah. So Shabhya, now you get it? You forgot to
Yes, sir.
subtract this one. Yeah. So the answer is 62 minus 6. So 6 factorial upon 4 factorial into 2 factorial minus 6. So this is 15 minus 6. So 9. Gautam, Ashma, Arsalan, Abdul, clear?
Sir, can you explain also?
Sure. See, we need the diagonal, right, Gautam? So a diagonal is also a line. And I know to get a diagonal, I need to connect 2 points, right? So if I write 6C2, that means I'm choosing any 2 points from these 6 points to get a line, right? But this adjacent points do not give me a diagonal, they give me the sides. So I subtracted all the sides. We have 6 sides in a hexagon. So whatever remaining has to be a diagonal. Is it clear, Gautam?
Yes, sir.
Yeah. So write it down. So if I ask you the same question about how many diagonals, in a 10-sided polygon, then what will be the answer?
10C2 minus 10.
Absolutely right. 10C2 minus 10. All right. So let's try another question. Count the number of rectangles in a chessboard. All right. We all about the chessboard, right? This has 64 squares. So count the number of rectangles in a chessboard. Right. This is a very ugly chessboard, but we have 9 lines here and 9 lines here. So this is a rectangle, this is a rectangle, this whole is a rectangle, right? So you have to count how many rectangles are there in a chessboard. Think about this in permutation and combination ways, right? Like the first question we did today, how many lines are possible? If you think about in that way, then you can easily solve. Anyone has answer?
1 minute, sir.
All right. Shravya, how did you get 64C16?
Sir, I consider total number of squares, and
Mhm.
then 16 means 8 plus 8, since there are 8 divisions.
Okay, but see, when I write 64C16, that means I'm choosing any 16 out of 64 squares,
Yes, sir.
right? So that is not the correct answer. See, think about this in this way. How can you get a rectangle? All right. How do you draw a rectangle? You draw two lines like this, two lines like this. This is my hint. Try to solve again. See, let me just solve this. All right. So we have the question was, how many rectangles are there in a chessboard, right? So look at this figure. To get a rectangle, you can choose this line and this line, this line and this line. So I got a rectangle. I could have choose this line and this line. Here the same lines. So another rectangle. Like that, how many rectangles are possible, right? So see, I can choose any two lines, any two vertical lines, or any two horizontal lines, right? Not or and any two vertical lines and any two horizontal lines, and that will give me a rectangle, right?
Yes,
So
sir.
9 vertical lines, 2 out of 9, so 9C2, and 9 horizontal lines, so 9C2. This is the answer. This is the number of rectangles in a chessboard. Clear?
Yes, sir.
Okay, write it down. All right, another question. Out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? All right, this is mixed type questions. Mixed means you need to apply arrangements and selection both in here, right? We have 7 consonants and 4 vowels, but you need 3 consonants and 2 vowels and make a word out of that. How many words like that are possible? All right, this is without meaning words. Try to solve this. Gautam, you also missed. See, this part is correct, but you need another thing to multiply here. You correctly chose 3 consonants out of 7, 2 vowels out of 4. Now you have to create words out of them also, right?
Yes, sir.
Yeah. So tell me the correct answer. Okay. Shabya, why do you use P here? Yeah, see, we need 3 consonants. All right, we'll be using C. 7 consonants we need 3. So 7C3, selecting 3 consonants out of 7, and vowels we need 2 out of 4. So 4C2. So now we have chosen 5 letters out of 11. Now we have to arrange those 5 letters to create as many words as we can, and that would be 5 factorial. 5 letters, 5 factorial. So this part, Gautam, Shabya, you both are missing, right?
Sir, why 5 factorial?
See, this, we just chose the consonants, right? How many ways can you choose 3 consonants out of 7? 7C3. How many ways can you choose 2 vowels out of 4? 4C2. Now the letters are collected in our bag. We haven't formed the words, right? They can be arranged in many ways. And how many ways can you arrange them? 5 factorial ways.
Yes, sir.
Clear?
Yes, sir.
Okay, write it down. Next question. How many words with or without meaning each of 2 vowels and 3 consonants can be formed from the letters of the word daughter. All right, try to solve this. All right, everyone solved it? Let's see. Consonants we have D, G, H, T, and R. Vowels we have A, U, and E, right? So we need 3 consonants, so 5C3, and 2 vowels, so 3C2. So 5C3 into 3C2 into 5 factorial will be the answer, because we need to arrange the letters. This is 5 into 4 upon 2 factorial 3, and this is 120. Gautam, how did you have 1440? I'm getting 3600.
Sir, I took 4C3 instead of 5C3.
Okay. All right. It's clear now, Shabya, Ashma?
Yes, sir.
All right. Next question. How many 4-letter words can be formed using the word failure? So that F is included in each word, F is not included in any word, right? Try to solve this. solve this question. Gautam, Shavya, Ashma, Salan. No one has solved this. All right. See, we have the word failure, right? The first part says F is included in each word. That means F is compulsory. We need 4-letter words. That means 3 are left to choose. So out of this 6, we have to choose 3. So 6C3, right? Now to arrange them is 4 factorial. So this is the answer, 6C3 into 4 factorial. In the second part, F is not included. So we have 6 letters and 4 to choose. So 6C4 into 4 factorial. This is the answer C. Is it clear, everyone? Shabya, Gautam, Ashma? All right. Next, last thing here in this chapter is write down gap method. Or keeping things separate. All right. We did something called bundle method, or we try to keep things in a bundle, right? Together. This is the opposite of that. Keeping things separate. Write down a question for this. A library has 3 mathematics, 2 physics, and 5 chemistry books. Which are to be arranged. On a shelf. In how many ways can you do this? These can be arranged. So that mathematics books are separate. Considering books of same subject are identical, books of same subject are not identical. All right. Write this question down, then I'll explain how to solve this. All right, everyone wrote down the question. Okay. So we have 2 physics books, 5 chemistry books, right? Whenever the question says we need to separate some things, first arrange those things that we do not need to separate. All right. I'm not arranging mathematics books for this moment, right? I'm just arranging these 7. So how many ways can I do this? 7 factorial upon 2 factorial into 5 factorial. Now the question says I need to keep them separate, right? So what I want to do is put them in these gaps between the letters. So how many gaps do I have? 1, 2, 3, 4, 5, 6, 7, 8. 7 letters, so 8 gaps. So I can put this in any 3 gaps out of these 8 gaps. So 8C3. Is it clear?
Yes.
Okay. Gautam, Ashma, Abdul, Arsalan.
Sir, can I explain, sir?
Sure. See, in this type of questions, the thing that we need to separate, put them in the later stage. All right. In the first step, I need to arrange all the things that I do not have any conditions for, right? And I can arrange physics books and chemistry books in any way I can. So I arrange them 7 factorial upon 2 factorial, 5 factorial, right? Now, because I want to keep these books separate, I want to put them in these gaps between these 2 books, right? Then they'll always be separated. So how many gaps do I have? I have 8 gaps, and I can choose any 3 gaps, and the condition will be satisfied that none of the books are together, right? So 8C3, choosing any 3 gaps out of 8 gaps. Is it clear, Gautam?
Yes, sir.
All right. In the second part, I have P1, P2, C1, C2, C3, C4, C5. Again, I can arrange them. So this is 7 factorial ways, right? Choosing any 3 gaps out of 8, so 8C3. But now because I have M1, M2, M3, they can be arranged internally also. So 3 factorial. Is it clear? This is arranging physics and chemistry books, choosing gaps, arrangement of gaps. All right, write it down. Is this method clear? Gautam, Shabya, Ashma.
So could you explain the second part again?
Okay, second part again. See, because all the books are different in this part, to arrange physics and chemistry books, I need 7 factorial ways, right? 7 things, 7 factorial ways.
Yes, sir.
And 8 gaps, I need to choose 3, 8C3. Now, as
Yes,
soon
sir.
as I choose 3 gaps, they can be arranged internally also, right? Because all the mathematics books are different also.
Yes, sir.
So 3 factorial for that.
Yes, sir.
Okay. So let's try another question. In how many ways 5 boys and 3 girls stand in a queue such that no 2 girls are together. Exactly 2 girls are together. All right, here the first part is exactly the same like the verb question. In the second part, you need both bundle method and gap method. So try to solve this. All right, solve this question. Gautam.
No, sir.
Okay. Ashma, Arslan, Abdul. All right, see. The first part is very easy. No two girls are together. All right. So Gautam, what is the first step to arrange the boys? Right. Whenever they say we need to keep things not together or separate, we arrange them in the later stage. All right. So we arrange the boys in 5 factorial base. So 5 things have 6 gaps and 3 girls. That means I can choose any gaps out of 6, 6C3. Now 3 girls can be arranged internally. So 3 factorial. Is it clear? Gautam, Ashma,
Sir, why 6C3?
see, because no two girls are together, right? That means I need to keep the girls separate. So I need to fill them in these gaps. So 6 gaps I have, but I need only 3 to fill 3 girls. So 6C3. Now these 3 gaps can be arranged internally. So 3 factorial. All right. Now the second part. Second part is interesting. They are saying exactly 2 girls sit together. All right. Exactly 2 girls, not 3. So first, let's create bundles, right? Whenever they say together, we need to make bundle. So we have 3 girls, G1, G2, G3. I need to create bundles of 2. So in how many ways can I do this? 3C2. 3 girls, I need to choose 2, right? Now suppose I created a bundle of this 2. So I have to choose this and this and need to keep them separate. I cannot keep them together. So again, I have to arrange 5 boys. So first step was to choose the bundle 3C2, arranging the 5 boys 5 factorial. Now I need only 2 gaps, right? One is this bundle, one is this G3. So out of 6, I need to choose 2 gaps 6C2. Now these gaps can be arranged internally 2 factorial. And in this bundle, they can be arranged, rearranged. So 2 factorial for that. This is the answer. Is it clear? I know these questions seem very tough, but once you get the steps, it's very easy. Shabya, Gautam, Ashma, Arsalan, Abdul.
Yes, sir.
All right, write it down. Okay, last question for this topic from this chapter, in fact. In how many ways the letters of the word imagination be arranged such that both A's are separate no two I's are together, vowels and consonants are alternate, two I's are together but separated
So
on third
vowels and consonants are?
alternatively, one consonant then vowel, consonant then vowel, consonant then vowel, like that.
Okay, sir.
All right, two I's are together but separated from third eye. All right, try to solve this all the questions we did previously, all the parts. So think very slowly, right, very clearly, then solve this question part by part.
Sir, second question is no two.
I's are together. All right, no two I's are together.
Sir, third one, last.
Vowels and consonants are alternate. No, Shabha, you need to think it again. All right, no two A's are together. So you need to put the A's in the letter stage. First, arrange all the letters except A's. All right, then choose the gaps. In the second part also, same method. If they are talking about no two I's are together, that means we'll arrange the I's in the later stage. First, we'll arrange all the letters excluding I. Then we'll choose the gaps and arrange the gaps. All right. Shravya, you almost got it right, but not 9 factorial, right? Letters are same also. So you need to divide by 3 factorial and 2 factors.
Yes, I was writing that in chat box.
All right, all right. Then it is absolutely correct. All right. Try the later parts. Yes, you need to divide by 2 factorial also, right? 2 n's and 3 i's.
Yes, sir. So for the second one, we should not consider the third eye.
No, no, no. That means all the i's are separate, right? If they are saying no 2 i's are together, that means no i's are together.
Okay, sir.
All the i's are separate. Yeah.
Sir, is the second answer correct?
Yes, absolutely right.
Okay,
Try the
sir.
third and fourth part. Gautam, are you able to solve this?
No, sir.
No. Just think about this, just like the previous questions, right? Try to solve. See, in the first part, they are saying both A's are separate. So first, let's write down the letters. We have I, A, N, and MGTO, right? All the letters are there. So they are saying both A's are separate. So excluding A, I'll arrange all the letters. 3 I's, 2 N's, and 4 this. So in total, 8, 9 letters. So 9 factorial upon, because we have 3 i's, so 3 factorial, 2 n's, and 2 factorial. Now 9 letters have 10 gaps in them, and I have to fill them with a's, 2 a's, so 10c2. I don't need to arrange the gaps because we have similar things here. So this is the answer to the first part. In the second part, same is for eyes. No two eyes are together, so I need to keep the eyes separate. So first let's arrange these. So in total we have 8 letters. So 8 factorial upon 2 factorial and 2 factorial, because 2 A's and 2 N's into 8 letters will create 9 gaps, and I have to fill 3 I's in them. So 9C3. Again, I don't have to arrange because they are identical. Clear, Gautam?
Yes, sir.
Let's try the third and fourth part. See, in Shabe, have you done the third part?
So I was not getting it.
Not getting it. All right. See, they are saying vowels and consonants should be alternate, right? So first, let's try to write down the vowels. In vowels, we have I, A, and O, right? And consonants, we have N, M, G, T, right? So, see, if I start with a consonant, right? If I start with a consonant, then suppose I fill this I here, then again a consonant, like that. In 4 letters, I have 5 gaps, but there are 6 vowels. That means 2 vowels will be together. Is it clear? See, if I start with the consonant, then vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel. I have 5 consonants, so 5 consonants are done. But I have 6 vowels. That means I have to write like this. So I cannot start with a consonant. I have to start with a vowel. Is this clear, everyone?
Yes, sir.
So what will be the case? A vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, like this, right? So how to do this? So first, let's arrange all the vowels, right? First, let's arrange all the vowels. So I have 6 vowels, 6 factorial upon 3 factorial into 2 factorial. Now I can fill them in these gaps: 1, 2, 3, 4, 5. So 5 factorial, but because 2 n's, so upon 2 factorial. Is it clear?
Yes, sir.
Okay. In the fourth part, they are saying 2 eyes are together but separated from third eye. So again, in here, let's make a bundle of this 2 eyes, right? And arrange all these letters. So if 3 eyes are gone, that means 8 letters are remaining. So 8 factorial upon 2 factorial into 2 factorial, right? Now I have 2 things. One is this bundle for 2 eyes, and one is this. And how many gaps I have? 9 gaps. 2 things to fill, so 9C2. And now I have to arrange the gaps, right? Because these 2 are different. So 2 factorial for that. This is the answer. I don't have to arrange them in the bundle because 2 eyes are identical. Is it clear?
Yes, sir.
Okay. Gautam, Ashma, Abdul.
Yes, sir.
Okay. So your permutation and combination is finished. Please complete the NCRT. Right. All the questions? All right. And
Yes,
now
sir.
we are going to start the chapter 3D. Just the introduction today. All right, 3D geometry. So we all know about 2D geometry till now, right? Everyone knows about 2D geometry. They have been learning about this since class 7th or 8th, right? What is that? X coordinate and Y coordinate.
So here we'll also use that coordinate.
Absolutely right. We had X axis, Y axis. This was X dash, this was Y dash. Here both the coordinates are positive. Here both the coordinates are negative. Is it right?
No, sir.
No, Y is positive here. Here both are negative. Here X is positive, Y is negative, right? So two axes divide a plane in 4 parts, right? This whiteboard is a plane, right? And this two axes divide that in 4 parts. That is called quadrants. Right? This is very simple. Quadrants, and we know this is called first quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. This is very clear to everyone. I hope all of us has learned this in previous classes. So why do you need to add a z-axis? In 3D, we need a z-axis. See, we learned about coordinate geometry to locate few things, right? If I have to ask you about where this point is, you will say, if this is the coordinate axis, you will say move in positive x direction for 5 units, then positive y direction in 2 units, you will reach the A point. But as we know, we live in a 3D world, right? Everything has length, width, and depth also, right? A river doesn't flow in 2D, it has 3-dimensional shape, right? A human has three-dimensional shape. Everything around us is 3-dimensional. So this study is incomplete. That is why we need to learn about 3D, 3-dimensional things. All right. Space is 3D. Okay. If I have a circle in 2D, in 3D it becomes
Sphere.
sphere. Absolutely. See, I cannot draw a sphere in 2D. So please use your imaginations in this chapter. All right. It's very necessary. I cannot draw 3D figures. If it is a square,
Cube.
I can try to draw like this, but still this is a 2D figure, but you have to imagine. If it is a rectangle,
Cuboid.
cuboid. Right. So for these reasons, we need to learn about 3D. Few things we'll learn in 11th and a lot of things in 12th. All right. So please focus on this chapter because this will come in 12th also. First, let's get clear about this axis. Also, you can name any axis, anything. This can be X, this can be Y, this can be Z. But my habit is this is X, this is Y, this is Z. All right. In different books, you will get different things. So don't worry about this. Just focus on positive x-axis, positive y-axis, and positive z-axis. And do one thing also. Wherever you are sitting, all right, look at any corner of your room, right? The line, see in above, if you look at the line going above, take that as y-axis. The line coming from the corner point to this side, your right side, is x-axis, and the front line is y-axis. Sorry, z-axis. And all this chapter will use this reference point. All right. Look at the room. All right. Take the lower corner point of the room in your front right side. The line that is going upside is y-axis. On your right side is x-axis. On your front is z-axis, because they are perpendicular lines. Is it clear?
Yes, sir.
Okay. Now, whenever I say or give a reference, you have to imagine the room, right? Because see, no matter where you are sitting in the examination hall or your room when you are giving the exams, you always have the walls, right? So it gets a lot easier to imagine the planes. All right. So this, if you are sitting here, this is your table and the laptop. This corner, this line is y-axis. Your right side, this is x-axis. This is z-axis. So the line going downside is y dash. The line going like this is x dash, and this is z dash. All right. So your room is like this. We have one room like this. Oh, okay, that in the later stage, I hope I can explain this. So now look at this wall, your right side wall. All right. This is a plane. This wall is a plane. And if imagine this is an infinite plane. All right. This is never ending plane. This is going upwards and forward also. Now look at the floor. That is another plane. Is it clear? Are you guys able to imagine this? Shabya, Gautam, Abdul?
Yes, sir.
Okay. So now we have two planes. One is this, one is this, right? So all the space in this world is divided into four equal parts, right? One is this, 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 right? One plane is cutting it in half, another is cutting it in another half. So four parts. Is it clear?
Yes, sir.
Now look at the front wall. That is also slicing the four parts in half. So in total we have 8 parts. Is it clear? Can you look at the 8 quadrants? 8 octants, sorry.
Yes, sir.
Okay, Gautam, Abdul, Ashma. If you cannot, then I have another example. Suppose there is a birthday cake, or it's your birthday, and your friends bring you a cake. All right. Suppose this is a rectangular cake, and what you do is take the knife and cut it like this in half. All right. Then your friend comes and see this. This is the front view, and this cake is sliced in half. This is front view. Your friend comes and cut it like this. All right. You cut it like this. Your friend comes and cuts it like this. Now another friend comes and cuts it like this. So we have top layer 4 parts and bottom layer 4 parts. So these are called octants. Is it clear how we get 8 equal parts?
Yes, sir.
All right. These are called octants. All right. So write it down. 3 axis. Cut the space in 8 equal parts, and they are called octants. All right. In 2D, they were called quadrants because we had 4 equal parts. But here it is octants. Right. In the next class, this is all for today's class. In the next class, we are going to see how we name these octants and which are the signs of these octants. All right. Positive x-axis,
Yes, sir.
negative x-axis, like that. Naming the octants. All right. So please be present in the next few classes because in 2 classes we are going to finish this chapter. All right.
Okay, sir.
So yeah. So next week be present, everyone. See you in the next class. Take care.
Thank you, sir.
Thank you, sir.
And please finish the NCRT permutation combinations also and ask me
Yes,
doubts.
sir.
All right. Okay.
Thank you, sir.